Hey guys, and welcome back. Today we're going to use what we've learned about logarithms to solve logarithmic equations. So when we have base 10, this is the easiest one because we do not need to use change of base. So we have 5 times 10 to the negative 2x power equals 33. The first thing I'm going to do is move the coefficient to the other side. Since 5 is being multiplied here, we're going to divide both sides by 5. So it simplifies to 1 on the left, and we're left with 33 over 5 on the right. Now we're going to leave it in fraction form so that we don't have to round. So now I'm at 10 to the negative 2x equals 33 over 5. In this case, my base is 10, my exponent is negative 2x, and my answer is 33 over 5. So we'll rewrite in logarithmic form. So remember, it's log base BA equals the exponent. So here we have log base 10, 33 over 5 equals negative 2x. Now, we don't need to write or care about really this base 10 because it's implied when you use the logarithm button on your calculator. So really we have negative 2x equals the logarithm of 33 over 5. Now the last thing we have to do to get the x by itself is once again move the coefficient over. So we're dividing by negative 2. So x is log 33 over 5 divided by negative 2, or negative 1/2 times the logarithm of 33 over 5. So if they ask you to just write the logarithmic expression that's equal to x, you'll stop here. If not, they want you to actually solve for it, you're going to plug this into your calculator. Negative 1/2 times log 33 over 5. And when you do, they're going to ask you to round to the thousandths place, which is 3 decimal points, and your answer here would be negative 0.410. Now, if you want to check your answer, you can plug this back into your equation for x. So you would be plugging this into your calculator. 5 times 10 to the negative 2 times negative 0.410. Because we rounded, it might be a little bit different than 33, but it should be close. And that's how you'll know you have your correct answer. Try another. 0.25 times 10 to the x over 4 equals 40. So what should I do first? Remember, we have to move the coefficient over, so you can divide by 0.25 on both sides. Now, in the last problem, I left it as 33 over 5 because that does not come out to a whole number. But 40 divided by 0.25 is 160. So here we're okay to simplify the right side. The next step is to write it in logarithmic form. Log base 10 of 160 equals x over 4. Remember, if it's base 10, you don't need to deal with that in your calculator or with change of base rules. So log of 160 equals x over 4. Last time, because we were multiplying a number by x, we divided by that on both sides. But here, since I have a 4 in the denominator, in order to move that over, I have to multiply both sides by 4. So x is 4 log of 160. So if they ask you for exact form, this is the answer. If they ask you to round, then you plug 4 times log 160 in your calculator, and your answer should be approximately 8.816. And remember to plug this back in to the original problem, 0.25 times 10 to the power of 8.816 over 4, and your answer should be approximately 40. So let's talk about a different type of logarithm, natural logarithms. When we talk about logs, that means we're implying that there's a base of 10. So if I have b to the power of x equals a, then rewritten in logarithmic form, it would be log base b of a equals x. Well, when we're dealing with natural logarithms, our base is equal to e. E is a constant. You can find the button on your calculator. It's kind of like pi. And if my base is e to the x equals a, then instead of using log, I'm going to use the natural log. So natural log ln base e of a equals x. And we're going to look at a couple of examples about how to do this next. Okay, so here we see 4 times e to the power of 1.5x equals 44. Whenever you see e, you need to be using ln, not log. The steps are pretty similar. First, we'll divide both sides by the coefficient, and that makes e to the 1.5x power equals 11. Now we'll write this in logarithmic form. I have the natural log base e of 11 equals 1.5x. Now, just like log 10, we can ignore the base, ln e, we can also ignore the base. So that leaves me with 1.5x equals ln 11. So to get x by itself, we divide by 1.5. So x is ln 11 over 1.5. You may also see the answer with a fractional coefficient. If I'm dividing by 1.5, that means I'm dividing by 3 over 2. When you divide by a fraction, remember you're going to multiply by the reciprocal. So instead of dividing by 3 over 2, I will multiply by 2 over 3. So these are equivalent expressions. And then if you plug it into your calculator, x is approximately 1.600. So just remember, if you see the e, to use ln instead of log. Okay, here, -6 times e to the 4x equals -76. I'll divide by -6 on both sides. Remember, if I have a negative over a negative, it becomes positive. And you can simplify this fraction by dividing the numerator and the denominator by 2. So e to the 4x equals 38 over 3. Now put it into logarithmic form. Ln base e of 38 over 3 equals 4x. We can ignore the base. 4x equals ln of 38 over 3. Divide both sides by this coefficient. Dividing by 4 is the same as multiplying by 1 over 4. So my x is 1/4 of ln of 38 over 3. This is exact form. And the approximate answer when you plug it into your calculator is 0.635. And just like with logs, you can plug this back into your calculator for x and make sure that your answer is pretty close to -76. But what about when the base is not 10? Here my base is 2. So we start off the same way. Divide both sides by the coefficient. 2 to the power of 4x over 3 equals 500 divided by 5, or 100. To write this in logarithmic form, and there's no e, so we're going back to regular log, log base 2 of 100 equals 4x over 3. Now, if you have a calculator that you can just type this in with a different base besides 10, you can go ahead and do that. Otherwise, we need our change of base formula. So remember, change of base, we take the log of the answer and divide it by the log of the base. So log 100 over log 2 equals 4x over 3. If I want to move a fraction to the other side, I simply multiply by the reciprocal. Because fractions, when we multiply, cancel diagonally. So x equals 3 over 4 times log 100 over log 2. So you'll go ahead and plug this into your calculator, and you should get x is approximately 4.983 to the thousandths place. And you can still plug this in for x and make sure your answer is pretty close to 500. Divide by the coefficient to get 4 to the 5x equals -75 divided by -3, or positive 25. Next, write into logarithmic form. Log of base 4 of 25 equals 5x. Change of base here would result in log of 25 over log 4 Okay, my x is still not by itself or isolated, so we have to divide by 5 on both sides, which is the same thing as multiplying by 1/5. So the exact answer would be 1/5 times log 25 over log 4. The exact answer, approximate answer in the calculator, 0.464. So as I'm doing these examples, you should be plugging this into your calculator and making sure that you can get the right answer. If you're struggling with typing this into your calculator properly, just please reach out and let me know, and I'll help you out. Together, divide by 6 on both sides. 3 to the negative x over 5 equals 36 divided by 6, or 6. In logarithmic form, log base 3 6 equals negative x over 5. Use your change of base. Log 6 over log 3. And negative x over 5 is equivalent to negative 1 over 5 times x. So in order to move the negative 1/5 to the other side, we'll multiply both sides by -5. So the negatives here cancel and the 5's cancel. And we move the -5 to the left. So in exact form, x is -5 times log 6 over log 3. Exact answer. Plugging it into your calculator, you should get approximately -8.155. So to avoid doing this multiple times, do the practice problems from the article or check your answer in your calculator before you type it in. Please reach out if you have any questions. Hope you're all doing well, and see you soon.